Howdy. This week, I'm going to talk about reasoning models, and I'm going to talk about some of the leading models coming out of Chinese labs. Now, why is this interesting? Because reasoning models have taken a significant step forward on what you might think of as ChatGPT. They have brought the ability of these models to the next level where you can actually use them. No, that's going a bit far. You can start to use them to find inconsistencies in documents, build high quality reports, for example. So yeah, I don't feel that they're quite there yet in terms of a lot of the human applications, but I'm starting to see them perform. And I'm going to go through 4 of the reasoning models that are out there in this video very quickly with one test example. And then towards the end of the video, I want to cover a latest Chinese startup model that has come out. It's from Minimax. Last week, or actually on Christmas Eve, there was a model from Deepseek v3 that is basically caught up to the state of the art in language models. And there's another one now from Minimax that's at a very same level of performance. So reasoning. Before I talk about that, just a general comment that discovery is very difficult, coming up with these ideas like how to do reasoning, as I'll describe. That's not an easy task. But once somebody does it, like OpenAI with their O1 or now their O3 model, which is not released, but they showed a demo before Christmas. When somebody does it, the fact that everybody knows it's possible makes it a lot easier to dedicate time towards. And so, yeah, doing it the first time can be very, very difficult. But once somebody does it, like the 4-minute mile, you see lots of people do it afterwards. And that's kind of what we're seeing with labs across the world, not just the Chinese labs. I suppose the Chinese labs, why am I breaking them out as separate? Because they are subject to export controls. And so this makes it interesting because it means to catch up, they can't rely just on compute. In fact, they're at a disadvantage. And when you see that the models are able to keep up, it means that there's something beyond just compute, maybe, is one way of saying it. But also it shows just how information disseminates pretty fast within this field. And if you come up with something, some kind of technique, there's a good chance either somebody else is going to find out or somebody else will be motivated to find it for themselves. Now, let me show you the significant advance I'm talking about here with reasoning. It's best seen by looking at this chart, which I'll admit is not the best chart, but it shows the performance on a benchmark called ARC AGI. And ARC and the ARC prize, which is a prize for reaching a certain threshold, albeit you have to not use more than a certain amount of compute, so it has not been won yet. But the ARC prize has long been able to withstand many of the latest models. So it's been really hard to score up to 80-90%, whereas many benchmarks have been saturated. The ARC prize benchmark has not. Now, it still hasn't been saturated by low computing power models, but it has, as of O3, we've reached, or OpenAI has reached very high performance on this. Now, it's a benchmark that's very straightforward. I won't say very, but it's somewhat straightforward for humans and difficult for AI. And here you can see in yellow, scoring above 75%, you have the O3 series of models. And then down here to the bottom left, you have O1 Mini and O1 Preview, which are the earliest versions of the reasoning models released by OpenAI. And pretty much all of the other language models, Claude Sonnet, I think, is maybe up a little bit higher here. So it's one of the stronger ones. But basically all of the models until the end of 2024 were very poor on the ARC benchmark. So something quantitatively different is happening here with this series of reasoning models. And it's been scaled by OpenAI to the level where this model is able to do very well on this reasoning benchmark. Now, I'll talk about high level how you do a reasoning model, but let's look at some examples in this test set. So here, it's kind of visual actually when you answer it as a human. You've got some examples. So here you've got an example input that's transformed to an output. Here's a second example transformed to an output. Here's the third one to an output. And now the question you have to solve, or the model has to solve, is going from this test input to this test output. So as a human, you kind of look at this and have some guesses. And you can see this gray one here. It's got this thing sticking out, kind of sticks out to me. And I can also see the gray box is slightly to the right of where it is in the input. And the blue, it's got the blue thing sticking out and it's slightly to the right. So yeah, basically I figured out here, this blue is being shifted by 4 to the right, the gray being shifted by 3 to the right. And yeah, that matches up, so probably true. Here the orange, it's got 2 sticking down. So it shifted down. So that seems to be the pattern. So if I was going to fill in this output, I would shift this light blue by 5 to the left, this by 2 up, and this by 2 up. So that's the answer. And actually, this problem here is an example of one that is not solved by O3. So even the strongest model available is not able to solve this. But many problems of this class, easier ones, are solved by O3 that previously weren't, and that would generally have been solvable by a human. Now, what makes this difficult? I won't say this is the only way to describe this, but what makes this class of problems difficult is that if you guess blindly, like imagine to create the output here, you just throw some random colors onto the pixels. If you just randomly do that, the search space, or not the search space, the space of guessing is so large, there's so many possibilities that it will be highly inefficient. So you need to have a way to kind of make reasonable guesses and then check if the guess makes sense. And that's kind of what I did when I showed you. You know, I had a guess here about it shifting, and then I kind of checked it and it checks out. So yeah, making good guesses and being able to verify them. They're the two core things. Well, the second one is the core thing that's present with these reasoning models that wasn't so much before. Reasoning models, they allow some ways to kind of check if they're right, and if they're not, kind of backtrack, or maybe at least rule out that as a possible solution and just move to another one. So this has been missing from, say, the ChatGPTs we're familiar with. And because of that, we have pure hallucination. There's no real verification. I'm not saying that this new series has got absolute ability to verify, but it has some ability to verify that greatly reduces and narrows down the amount of guesses it has to make. Now, it's still way less efficient than humans. Each guess took up to $2,000 in the top performing case to compute the answer, which is way more computing power than, say, my brain would be doing in watts or dollars. So yeah, this is the ability that these models have been able to achieve. And just to explain a bit further, now that we have this reasoning background, before the O1 series of models, there was no, what I'm calling here, there was no training on reasoning traces. I'll explain that in a moment. And as we've moved from O1 up to these larger models, there's a few things happening. One is that simply a lot more compute is being used, which means a lot more attempts at the problem are being taken within each stab. So that's improving. And then also presumably the data, which we don't see, but the data that OpenAI has used to train these models has improved over time. So now that OpenAI has got a model, of course, everybody else now has to get out models as well. And that's probably an unfair characterization, because in literature, there are quite a few approaches around reasoning. OpenAI had a paper about how to take this kind of approach, including with author Ilya Sutskever on it back a few years ago. So it's not like this is totally new, this addition, let's say, to the original GPT-3, but it's something that OpenAI has come out first with, and now we're seeing catch up from other models. And I'm going to go through some of those. So I'm going to go through Deepseek, which is a Chinese company. I'll go through and show you how their reasoning model works. I'll show you how O1 works. I'll show you then how Gemini has a flash thinking. This is from Google. They have a thinking model. And then Qwen, which is another model from a Chinese lab. Just before that, I'm not going to go into full detail on exactly how the reasoning works. You can maybe check out some of my videos on test time inference, which talks about how you use the same model to have multiple stabs at the same problem and ideally pick out the best stab that the model had at it. But in simple terms, what's missing from the earlier models is training on these reasoning traces. A reasoning trace is a series of thoughts around how to solve a problem that might include kind of going down something that turns out to be a dead end, realizing it's a dead end, turning around and coming back and trying another direction. Or it might involve finding a promising lead and kind of pursuing that for more steps and abandoning some kind of fruitless efforts towards solving the problem. Now, why wasn't it obvious to just do training on these what are called reasoning traces or paths in the first place? Well, it's not so common for people to write those down. It's not like they're available on the internet in the same way books or knowledge is available. So crafting these reasoning traces is non-trivial. How do you just come up with and generate them? And the way they're generated now, which has been a series of iteration. And I don't claim to fully understand how OpenAI do it. But it turns out you need to have an ability to verify the path that you're taking. So you come up to, say, a maths problem, maybe the first part, you try, I don't know, turning the problem upside down. That looks promising. You need a verifier that tells you you're on the right path, and then whether you should either just dump that approach or move on to another one. So the question becomes, how do you train verifiers to tell you you're on the right path? If you do have a good verifier, you can start to craft these paths of reasoning and use those paths in order to train your model. Now then the question gets kicked to, how do you train good verifiers? And there are a few different ways. I won't get into too much detail. One is to use Monte Carlo, which is kind of to simulate a lot of possible outcomes of that path. And if those outcomes tend to be good, you can say it's a good path. If they tend to be bad, you say it's a bad path. Another approach is to use human labeling. So you can get humans to label the approaches, the steps involved in problem solving. And it turns out that might be the main approach that's being used right now, the human labeling. You can kind of use LLMs to assist in that. But the Monte Carlo approach, I think, depending on the paper you'll read, there'll be claims that it actually isn't very robust in identifying strong paths of reasoning. Okay, so suffice to say that these models, which I call reasoning models, I call them that because they are trained on a lot more reasoning content. That content is not trivial to generate, but if you can generate it, you're now able to get much better exploration of a problem. And to be clear, these most powerful models here, as well as kind of exploring through this reasoning path, which is just generating literal thoughts, they will run multiple in parallel. And when they run many, many, many in parallel, they will use that verifier to decide which of them is best and which they think gives the most correct answer, and use that as the final answer to the problem. Okay, that was a lot more theory than I expected. So let's take a look at a practical use here. And I'll start off with ChatGPT, which has got the O1 model available. Maybe for everyone. I'm on ChatGPT Plus, so 20 per month. And I have this, I often reach my limit. If you pay 200 per month, you can get O1 Pro, which is O1, but running with more compute. So it will basically run out the train of thought for longer. You can think of that, it's a bit oversimplified. Now, O1 is available in the API, so you can integrate it into products. If you want it integrated in your business, you'll want to find some software or business that has access to O1 because it's only available on tier 5, which means you must have spent, I think, at least maybe $500 or $1,000 worth of credit in order for it to appear in your API. And O3 is not available, neither in ChatGPT nor in the API. O1 Mini and O1 Preview, which are the ones scoring lower down here. And I definitely notice a big difference in abilities when running these models versus running O1, some of these, or and I can't run O3. But even the difference between this and this, well, it's a factor 2 even on this graph. I'd say it feels like more when I'm running them in practice. So the problem we're going to test is based on passing in a long transcript. So I've got this transcript here from Berkshire Hathaway. And let me bring it onto my screen. It's the 2023 meeting. And what I've done is I've just introduced an inconsistency here. Yeah. So I've made Tim Cook the CEO of Orange instead of being the CEO of Apple. So that's an inconsistency. And I would say that's a pretty blatant inconsistency, at least to me as a human. I've put in a more subtle one as well, which is to do with the interest that was being earned by Berkshire on its cash pile. So it was earning 4 basis points when interest rates were low on 125 billion. 4 times 125 is 500. So they should have been earning $50 million per year of interest. And I swapped it from 50 million to 25 billion. So I've put in a numerical error as well. Now, this is the type of error that I think is very important in many applications to find. And it's useful if a model can find it. We'll see if it does. So I've one maybe more blatant and one then kind of tricky error. And I've put that into O1 here. And the question I've asked is simply find the inconsistency introduced. Now I've run that, and O1, fortunately in the interface, it's quite finicky. If you put in long context, it often will just kind of look like it's crashing. If you give it some time though and refresh the page, you'll often find that the answer is actually there. So that's what I'm hoping for. Okay, well, ChatGPT doesn't want to cooperate, so I'm going to come back to that. But let's take a look at Deepseek. So Deepseek has got its own reasoning model. It's called R1, and it's available within the chat interface. So you do have to set up an account by, say, signing in with Google. And this is from a Chinese high-frequency trading firm that has gotten into language models. But Deepseek is one of the strongest models that's out there now, and it's actually open source. This reasoning model is not open source, and it's not available via API. You'll only see the Deepseek chat model, so you won't be able to find the reasoning model. But you can use it in this chat format here. And I've put in the exact same question, find the major inconsistency introduced. And I'll just run it again in a new chat and click on Deepseek, which is allowing the reasoning. And let's run it here. And you'll see it actually outputs the answer in two parts. There's kind of this loose reasoning part where it says, okay, it's kind of casual. I'm trying to figure out what a major consistency is. First, I see there's a lot of talk about the first quarter earnings. Another point about Ajit Jain is the insurance float, et cetera, et cetera, et cetera. So yeah, it's going through this in a somewhat casual, including some Chinese tokens here. And it comes out and then kind of gives a clean answer at the end. So it's allowing for this kind of reasoning before giving a clean answer. Now, it's not getting either of those. So I'm just going to type in nope and give it one more go, and we'll see how it performs. I will go through a more detailed and formal analysis of these reasoning models in probably the third part of my evaluation series. And I'll show you there some examples around inconsistency checking and how you can improve performance a little bit. So for now, this is a little bit casual, but it does show you how this works. It doesn't manage to find any of the key errors, unfortunately, in this case. The next one I want to look at is Google's Gemini. And there's now a Gemini 2 Flash Thinking experimental. So kind of in the same style, they've introduced thinking. And when you put in that text, the very same prompt, sorry, a spoiler here, it does actually find the inconsistency around orange. And it does so by producing some thoughts beforehand. I'm not sure if these thoughts are maybe redacted slightly, or they're the exact thoughts, maybe summarized version of kind of the longer thoughts we saw in Deepseek. But you can see here the model is doing well. So it's finding that orange as being swapped. It's not finding more difficult interest rate question though. And the last example I show you, although I'll go back to ChatGPT, is that from Qwen. So Qwen is associated with Alibaba, the Chinese e-commerce company. And Qwen is a model on reasoning called QWQ. I've just pasted in the text. Just the tip, you'll be limited how much text you can put in here to Qwen unless you go to settings, and within settings, right here within interface, you need to turn on paste large text as file. And this will allow you to paste in up to, I think, about 100,000 tokens. So here, yeah, it's not finding the inconsistency in this case either. Let's go back to O1 and check out ChatGPT. Hopefully the model will start for me. Okay, it looks a bit better this time. And let's check the inconsistency here. Okay, so yeah, it does find it. It finds the slip in orange, and it does not find the inconsistency around interest rate. Now, you'll notice I did ask it for one inconsistency. You could say, oh, that's why I didn't find the other one. But no, I left out the inconsistency about orange, and the model did not get that change in the interest rate. Well, the calculation that I changed, it did not notice that was an inconsistency. So this is the performance across the current reasoning models. They are improving fairly rapidly. I think for me, O1 is useful. I use it on a daily basis. I'm quite impressed with the Deepseek model. I think it's the best of the other reasoning models, although the Flash model is quite good too. And it has the benefit here with Google. I think it's possible to put in up to 1 million tokens of input, which allows you to reason with very long documents. So as with the Gemini models, I'll have to check that, double check that, but I think it's the case. You can reason over very long documents now with thinking mode. And I think for a lot of enterprise use cases, you should be working with reasoning models right now. That is the state of the art. You will get better performance. If you're not using it, you can get it with OpenAI if you have a Plus or if you have a Pro subscription, but you can also get it for pretty close to free if you just use Google, because they're putting their pricing extremely low and allowing people to use AI Studio for free. Okay, so this is reasoning. There's something that came out this week related to reasoning that I'll touch on before I talk about Minimax. And that's something that came out is the Qwen process reward model. The process reward model is something that you need. Well, we suspect you need if you're developing these reasoning models. It's essentially that verifier I was talking about. So it won't just tell you the answer is right or wrong, but it will kind of grade how you're doing on a given step of your reasoning. And it's called process reward as opposed to outcome reward because it's able to grade along the way of the solution, not just grade based on the final solution that is there, which is generally easier because you know the final solution if you have some data set. So this has been released publicly, the process reward model. This has been used, presumably, or maybe even confirmed, in order to train this Qwen reasoning model. Now, in my experience, the Qwen reasoning model is maybe similar to O1 Mini, maybe a little bit weaker. You can see here on this chart, there's no Qwen, but if you were to put it in, it would be maybe somewhere down here. My guess is Deepseek is maybe somewhere in this region here with the reasoning model. I think it's quite good. And Gemini, maybe somewhere here in the reasoning model too. There's pros and cons though. Gemini can handle a longer context. So this is the process reward model, and it's nice to have it open source. In fact, I should have said this model here, QWQ, is open source, so you can use it via API, for example, on Fireworks. And there's probably some other provider as well, I think through Alibaba Cloud, which I have never tried. So this is pretty much the status of the reasoning models. They have not really yet come to agents because they don't have tool calling. Tool calling allows you to connect to APIs, for example, or to search the web. And that is really what's meant by agents. When there's all this modern talk of agents, it's just a series of steps, a program, if you like, where at least one of the steps is a language model deciding what the next step should be. That's really what people mean by agents nowadays. And when the reasoning models come to agents, that will be a significant boost. So I would say we're not really at that step yet. I think you can maybe use O1 within some coding tools, but the integration is somewhat loose until the tool calling. So until there's kind of this tight link that allows you to basically get the model to specify, yes, I want to use this tool with this specific syntax. So moving on, let's talk a little bit about the emergence of these strong models from Chinese companies, namely Deepseek from that trading company, Qwen from Alibaba, and now Minimax, which is a company that's been around a while maybe, but has just released a model that is pretty much state of the art. And it's very much similar to the Deepseek V3 model that was released and is comparable in performance to GPT-4o and Claude Sonnet. Now, I think the thing, if I was to say that's underappreciated about the Deepseek model, because it's been talked a lot about in the news, it took $5 million to train. And I don't mean to discount that. That should be, that's very important. That's a lot less than it would have taken probably OpenAI to train. Maybe it would have taken 10 times the amount to train a model of the same power. So it's very significant, the reduction in compute that was achieved by Deepseek in training their model. In fact, let me just, this is the technical report here from the paper. But I think what's underappreciated about this report is that what Deepseek showed, they showed a few different things, but one of the key things is that they can make mixture of experts work, supposedly. We can't verify they spent exactly this amount of GPU hours, but if what they say is true about the number of GPU hours, that means their mixture of experts approach is very, very efficient. And that has been a problem because if you look at the history of how models have evolved, there was GPT-3, and GPT-3 is a single transformer. So it's a massive block of matrices, of neural nets. And after GPT-3, there's GPT-4. And GPT-4 moves to this, what's called mixture of experts. Mixture of experts means you have multiple models. It's actually multiple models at each layer of the transformer. But essentially, you can think of it as multiple models. And you have these models as experts, and you only query one of them at a time, or maybe 2 out of 8, or recently with Deepseek, a much larger number, like say 32 out of 300, something like that. So you've very large granular experts, and then you pick a few of them to give you advice on the next token. So anyway, GPT-3 to GPT-4, there's this move going to mixture of experts. And the idea with mixture of experts is they are quicker to run because instead of having to compute every expert for every question, you just compute a small number of them or one of them. So you have to do way less computation in getting the answer. But the problem is that they're very difficult to train because it's very hard to balance the knowledge amongst all of these experts. And that became, and this is partly speculation, but I think empirically it's borne out, because if you look at, say, Llama 1, Llama 2 from Facebook, they're not mixture of experts. Llama 3, not mixture of experts. And Llama 3 included a huge model of 400 billion parameters. Now, if Meta had confidence that the mixture of experts models were straightforward to train, they probably would have done mixture of experts. Mistral, likewise. Mistral initially released Mistral 7B, but then they moved to doing mixture of experts with 8x7B and 8x22B, so 22 billion parameter experts, 8 of them. But then for Mistral Large, they moved back to a single model, which I think has over 100 billion parameters. So again, if it was clear that training these mixture of experts made sense, and kind of in theory it makes sense because they're quicker to inference, you only inference one expert. Even in theory, they're quicker to train because every token only has to go through, 1/8 of the experts or whatever the ratio is. But in practice, I think that was very difficult because of this balancing problem. So I know I'm going kind of a long way around to say this, but Deepseek, I think, is one of the examples of where they probably have figured out the balancing. And if you've figured out the balancing, and by which I mean, when you train, you pass each token in the raw data and you kind of manage to spread them out evenly amongst. And I go into much more detail about this in my video, Deepseek v3. But if you manage to do that, you do cut the amount of compute by a factor of, say, 8 or 10. And this, I think, is the biggest factor behind how Deepseek were able to train their models so cheaply. And it's basically a similar approach that's been taken by Minimax. I'm not convinced Minimax have got the balancing quite as good as Deepseek. It's something that's hard to gauge, but they've technically used a different approach, and they have, if you want to dig in, they have token dropping, which means effectively they don't perfectly balance. They have to throw out some tokens that just kind of go unused in order to get the balance. So the fact that there's token dropping suggests to me that they haven't achieved the same balance as Deepseek, but nonetheless, they must have made it work good enough to get significant reduction in training costs, potentially. They don't emphasize training costs quite as much as Deepseek. Now, what Minimax does, and can I scroll up and show something here? Yeah. I'll tell you in a second what Minimax does that others don't, or rather that others do, but Minimax is highlighting in open source. So here you have some different metrics, different benchmarks like MMLU. This is really tiny, but the red is Minimax. And then moving left to right, so you have GPT-4o, Sonnet, Gemini 2 Flash, which, to be honest, is a bit weaker than Pro in some cases. So I think maybe they should have shown Pro. Qwen 2.5, this is one of the strongest models from Qwen. Deepseek v3, which came out Christmas Eve, and then the biggest Llama model. And yeah, you can see the dark red here. It's doing well, if not beating a lot of the other models. And GPT-4o and Claude 3 Sonnet, these are state-of-the-art models today. Now, none of these are reasoning based, although Deepseek v3 does actually use some reasoning data. So I think the line is getting blurred between being, and will increasingly get blurred between being reasoning or not, because all of these reasoning traces and these models that can do parallel reasoning, evidently that's going to give good quality data. And so this is going to be a source that will be used to put back into the models, and the lines will increasingly get blurred in the same way that the lines are getting blurred between human and synthetic data. Anyway, that's a sidebar. The point from this graph is that the Minimax model is really good. It's not just really good, it's really long. So it's able to take in text up to 1 million tokens in length, which is kind of in the same ballpark as Gemini from Google, and is 5x longer than Claude or 10x longer than GPT-4. So pretty strong model. And what's allowing them to do this long context is probably also what's allowing Google to do this long context. Although Google also has got TPUs, they have their own computer chips that gives them a significant cost advantage. So that's a big factor that probably others don't have. But what allows long context is actually kind of making a transformer less of a transformer. What makes a transformer is the fact that every token, when you're predicting the next token, you look back at the relationship between this token, like say the quick brown fox, when you're predicting the word after fox, the word fox will look back at the quick brown, and it will look back at every token, even if there's 100,000 tokens, if you allow for that. You're going to look back and calculate those relationships. And that results in quadratic complexity, because every token needs to look back at every previous token. So you have this kind of multiplicative effect. And that costs a lot in terms of compute when you have a long context. But it turns out you can get away with doing this not in every layer of the transformer, because the transformer is a neural network that has many layers, maybe 30, maybe 60, maybe 100. You can get away with doing it maybe 1 out of 8 layers. And I can't remember exactly where I saw this mentioned before, but I believe that some of the Google models, one of the inference tricks that was used by Google, or probably still is even after having trained a transformer with every layer looking back, they would just, at inference, not look back in many of the layers and just do it every 2 layers or every 4 layers. And that kind of skipping of full softmax attention and using linear instead, that allows you for avoiding a lot of compute. And so what Minimax shows is that you can do this, and you can do it when you're training as well. You actually don't need kind of the full transformer attention in every layer. You can just do it 1 every 8 layers, and this greatly reduces the compute that you need. So this is one of the contributions. Definitely I'm not doing justice by going through this in more full detail, but there's a lot here that's similar as well to the Deepseek paper, and you can take a look at that Deepseek video if you're interested in a bit of a more technical deep dive. Now, I did inference this Minimax model. You can reach out there's an email on the website. I got $50 in developer credits, so I was able to run via an OpenAI style endpoint. And by the way, Gemini now has an OpenAI style endpoint, so you're able to inference it using the same way that you inference OpenAI. Claude does not have that yet. So I did that, and I ran inference. I got about 35 tokens per second from Minimax. That's probably about half of what Claude GPT-4o and also Deepseek provide. So a little bit slow, but probably they'll increase it over time. Something that I'm a bit confused about is it strikes me some of the tokens per second for these mixture of experts are a bit too low. When you're doing mixture of experts, you should have very fast inference because you're bottlenecked by the expert size, which is a lot smaller than the full model. So you should be able to run really fast. Now they are more complicated because you have to manage the experts. So there's some optimizations there. But yeah, always strikes me as a bit weird when I see low tokens per second from models that are supposedly optimized mixture of experts. And that's pretty much it for this episode. My conclusion on these frontier models is that information travels really fast. I suppose people are able to move companies, at least say between OpenAI and Anthropic and Google. There's a lot of movement, so it's very hard for ideas to stay undiscovered. And as I said at the start of the video, once people know something is possible, that is often enough for others to have the determination, because they know that there is a way. And when you know there is a way, you will find a way.